Hello everyone and welcome once more to this video series. So we are going to be looking at complex numbers. So I've been given a complex number and we're asked to select um, which expression is equivalent to the given complex number. So we have been given that z is a plus bi. Then what is the expression? What is 1 all over z squared? So this is a very interesting question, and you know, we're going to look at it together. So, um, a brief definition. We're dealing with complex numbers. We know for a complex number given as z equals to a plus bi, then a here is the real part and b is the bi is the imaginary part. I squared is -1, or the square root of -1 should be I. So we have to have this in mind before doing any computation when it comes to complex numbers. So, but coming back to what has been given to us, we have a complex number z to be that, and we're asked to look for the expression of 1 on z squared. So we know that z is that, therefore z squared will simply be a plus bi all that squared. Now to compute this, we do the multiplication. It will be a squared, which will be a squared. Now bi squared will be b squared, right? But I squared is -1, so we're going to have minus b squared. So plus 2 times the product of these two, bi. So clearly we notice that the a squared minus b squared is a real part now, since it doesn't contain the I, and the 2abi is the imaginary part. So this is the real part. So having this in mind, we are going to simply replace it in our expression. We know we were given the expression was 1 on z squared. So this will simply be equivalent to 1 all over now a squared minus b squared plus 2abi. Now we have something like this. We cannot actually do any calculations. In fact, it's advisable once you have a complex number with the imaginary part, in fact, once you have a complex number with the imaginary part in the denominator, always try as much as possible to rationalize or to take the conjugate. So taking the conjugate of this complex number means that we're going to multiply the top and the bottom by the conjugate of the denominator. We know if you have a complex number z to be a plus bi, then the conjugate represented as this, or z star, will simply be a minus bi. So we're going to apply the same thing here. Knowing that this is our real part and this is our imaginary part, the complex number, this is z squared to be that. So the complex conjugate will simply be a squared minus b squared, so minus 2abi. So we are allowed to do this. And once we multiply the top and the bottom by this complex conjugate, we haven't really changed anything. It still remains the same. So that's why you haven't created anything, and you haven't like done a mathematics fallacy. So if we were to do that, we're going to have this. So we're going to see, multiplying the top and the bottom by that, we're going to have let me arrange this. Good. So we're going to have a squared minus b squared, now minus 2abi. We have that. So the same thing, a squared minus b squared minus 2abi. Good. So we notice that we haven't changed anything in this complex number, because this can actually cancel with this and it remains the same thing. So if we see that here is 1 times that is going to give us 1. So we're going to have 1 in the numerator, not 1, actually not 1. So we're going to have a squared minus b squared, so minus 2abi. Good. And in the denominator, we are going to realize a property. Now let's take it here. We know that a squared minus b squared can be written as a minus b times a plus b. So if we realize that, we see that this is actually exactly the same as this, but the only difference comes in with the negative and the positive, right? Meaning that this is actually the same property here, like it's a difference of two squares, meaning that we're going to write this in a special way. So we are going to actually apply this whole idea here, since it's a difference of two squares. And if we do that, we are simply going to take the first term, all that squared, meaning that we're going to take a squared minus b squared, all that squared. Now minus, right? Now the second part is 2abi, all that squared. So I hope that is clear enough. If it is not, you can put in the comment section. So a squared minus b squared, so minus 2abi, right, divided by, now we have this. Let's just simplify what we have. So this will be a squared minus b squared, right, all that squared. Now this here becomes 4a squared b squared. Now I squared becomes -1. So if we bring the negative here, it becomes positive. So we need to really take note of this. So it becomes positive, it changes to positive. So we have to really take note of that, because if you miss that, you miss everything. So having that in mind, we're simply going to now expand our function. We have a squared minus b squared minus 2abi, now divided by, expanding this is the same thing. We can have this to be the same as a squared minus b squared, or that a squared minus b squared. So it's the same thing. We're going to have a to the power 4 plus b to the power 4 minus 2a squared b squared. So this can be written down in the denominator. We're going to have a to the power 4 plus b to the power 4 minus 2a squared b squared. So since plus 4a squared b squared, now this is going to simplify something. It's going to simplify something. So if we look at that very well, we see here that the numerator remains the same. So it remains the same, but the denominator is going to change. That's where my interest lies. So the denominator here, we're going to have a squared, a to the power 4th, plus b to the power 4th. Now plus 2a squared b squared. That's what we have here. Now what this is also like a squared. If we look at it very well, we see that this is equivalent to a squared plus b squared, all that squared. If you look at it very well, this is what you're going to have. So there are so many ways to go about this. So having that in mind, we're going to have our numerator was a squared minus b squared minus 2abi, and now our denominator becomes a squared plus b squared, all that squared. So we have to separate the real and the imaginary part. Now there's a property we can apply here. We know that if we have a minus b divided by c, we can write this as a divided by c minus b divided by c. So this is allowed, but the other way around is not. So be careful when you're dealing with this. Now why are we doing this? In order to separate the real and the imaginary parts. So if we do that, we're going to have a squared minus b squared, now divided by a squared plus b squared, all that squared, right? And minus, or we can even write plus, now minus 2abi divided by a squared plus b squared, now all that squared. So looking at this, we see that we have separated our complex number. This is the real part of 1 all over z squared, and this is the imaginary part of 1 all over z squared. So usually these are usually MCQ questions, and to have the solution, you simply follow these steps. And if you have a complex number in the denominator, take the conjugate and separate your fractions, and you have something like this. So that's actually the solution. And from here, the MCQs that will usually follow will we just have to change some signs here just to confuse you, but if you are able to follow through these steps, you know that you will not choose the wrong answer. So that's it for this video. And if the video was helpful in one way or the other, please give it a like. And if you think someone might be the video might help someone, please just share the video and comment any video lesson you want you're facing difficulties in. I will create a video on that and respond as soon as possible. So thank you all for watching, and as always, you guys take care and see you in the next video.